Morning. I am ELAYA, working as Assistant Professor, Department of Physics, St.Joseph College of Arts and Science, Cuddalore. So today I would like to discuss about some few topics in classical mechanics. So in this classical mechanics, I am going to discuss about the concept of constraints. So constraints. So before going to the constraints, first of all, you have to know about the what is meant by degrees of freedom. Degrees of freedom. So degrees of freedom is nothing but a mutually independent variable. Mutually independent variable. To completely specify the state or position of a particle. So degrees of freedom is nothing but a variable, independent variable. So which is used to define the state and position of a particle. So if we consider a ideal mass point, so for defining or we have to find the position of the point particle, we need three coordinates x, y, z. So we need three coordinates for stating this particle x, y, z. So we shortly call this for this ideal mass point 3 degrees of freedom. Three degrees of freedom for this ideal mass point. For single point, we can write 3 degrees of freedom. For more number of particles, we can generalize the degrees of freedom. Shortly we call this DOF is equal to 3n. Here n which represents the number of particles. Here n which represents the number of particles. So this is the general expression for degrees of freedom. D of f equal to 3n. So kindly remember these values here. So next we go into the previous topic, constraints. So what is meant by constraints? We have to apply some restriction. We have to apply some restriction on the particular system. It may be any movement or any physical variables. We can apply some restriction on the particular system, then we call this constraints. So there is a general equations connecting the constraints and degrees of freedom as a relation between constraints and the degrees of freedom, which is equal to 3n minus k. This is the important relation, 3n minus k. This is the relation between the degrees of freedom and the constraints. Here k which represents the constraints. K which represents the constraints. So now we'll look at some few examples for clarifying the concept of constraints. Look at those examples. Beads on a abacus. You consider the abacus, there is a beads which indicates there is a restriction on the movement of the beads. What is the restriction? It can be moved or it can be only moved to and fro or anything along the wire only. Along the wire it can move anywhere place. Along the wire it can move anywhere. Beads, apagas, movement one-dimensional movement. This is the one type of example for defining the concept. So another one is gas move on a container, gas particles. So here the restriction is it can move only within the container, it cannot be able to move outside the container or cylinder. So this is the another restriction for the movement of gas particles. Then the third one, a rigid body. We know the meaning for rigid body, a defining body. The distance between, here we consider the rigid body to any shape. The distance between two particles on the rigid body it remains constant. We know, well known. Remains fixed or remains constant. The distance between two objects or 2 points in the rigid body will remains constant. So this is the restriction or this is the constraints we created in the rigid body. Then the fourth one, object move along the sphere. Object move along the sphere. So it can be moved along the surface of the sphere only. It cannot move outside the sphere or cannot be inside the sphere. So this is the restriction for the particle move along a sphere. Okay. So one more thing, you can split the movement of objects into plane and free space. When an object moving along the plane, we can mention as 2n. When the object moves along the free space on 3-dimensional, we can mention along 3n. So now we substitute the constants value minus k minus k. So this is the general equation for when the object moves along the plane. This one for a free space 3n minus k. So here we going to see one more short problem. Dumbbell. So dumbbell shaped, it looks like this. We know the meaning for dumbbell. Move in space. A dumbbell shaped object move in a space, then we have to find out the constraints value for this one. So which formula we are going to apply, whether we apply 2n minus k or 3n minus k. Since it moves along the space, we can apply the relation 3n minus k. We know the meaning for n, number of particles. So here apply this formula 3n minus k, n which is the number of particles. Constraint is only one, that is a rod is connecting the two objects. Then 3, number of particles is 1, 2. 3 into 2 minus 1 which is equal to 6 minus 1, 5. So for this double shaped, the degree of freedom gives what? Number 5. So since the double shaped, there are two objects, two particles. So for n value here we put 2. Since it is moving along the space, so use the formula 3n minus k. Constraint, there is a constraint. The rod is connecting the two particles. So finally we can get degrees of freedom for double moving the space is 5. Thank you.